Welcome to Networks Professionals.
All right, let's dive right into this explainer and demystify exactly how DHCP Relay keeps our networks running so smoothly. If you've ever dealt with network architecture, you already know that connecting devices across different subnets, well, it's basically the backbone of a solid IT infrastructure. So today, we're going to break down the exact mechanics of DHCP Relay. It's an absolutely crucial tool that lets a single centralized server handle IP assignments across a whole multitude of networks. To really grasp why this is such a game changer, let's put ourselves in a practical scenario. Picture this. You're managing a corporate network. You've got a massive headquarters, maybe a few branch offices, dozens of different departments. Now, a user plugs in a brand new laptop on the third floor of a remote branch. How on earth does that device get an IP address when your main DHCP server is sitting in a completely different building miles away? It sounds simple, right? But as we're about to see, the underlying architecture makes this surprisingly tricky.
And that brings us to Section 1, the broadcast boundary problem.
Okay, so here is our core problem. When a new device connects, it blindly sends out this loud local broadcast. It's called a DHCP Discover. It's basically shouting to everyone on the local network, hey, I need an IP address. But here's the catch. Standard routers are designed to be like brick walls for these broadcasts. They intentionally block them to prevent network congestion. Honestly, if routers just passed every single broadcast message along, entire corporate networks would literally grind to a halt from the sheer volume of chaotic traffic. So because standard routers block these shouts, it creates what is essentially an isolated island. The device's desperate cry for an IP address simply cannot cross the network boundaries. It's stuck. Without a relay mechanism, that device would completely fail to get an IP. I mean, the only way around this roadblock would be going through the absolute nightmare of physically installing a dedicated separate DHCP server on that exact same local network just to hear that local shout.
Which leads us to the hero of our story in Section 2, introducing DHCP Relay.
Now, instead of blowing your budget buying and maintaining separate servers for every broom closet, VLAN, or branch office, let's look at the elegant solution network engineers actually use. DHCP Relay acts as this incredibly clever translator. It captures those local broadcast requests and literally converts them into direct unicast messages, forwarding them straight to the server. Think of it like taking that localized, chaotic shout from the new device, writing it down, and slipping it into a directly addressed envelope bound straight for the central boss. It totally bypasses the router's broadcast block by changing the fundamental nature of the message itself.
Let's slow down and look under the hood in Section 3, the four-step process.
So there are 4 distinct methodical phases to this operation that flawlessly bridge the gap between an isolated device and your central server. We've got the broadcast, the capture, the conversion, and the response. Let's walk through exactly what happens at each of these crucial junctures.
It all kicks off with Step 1, the broadcast. A client device connects and just blasts a DHCP request out onto its local network segment. It's blindly searching for an IP address, sending a message to every single device in its immediate vicinity, just crossing its fingers that a DHCP server is listening. Then we hit Step 2, the relay captures. Instead of that broadcast hitting a brick wall at the router and being dropped into the void, the local router or switch, which you've configured specifically to act as the DHCP relay agent, intercepts this broadcast. It's essentially sitting there, actively listening for these exact cries for help. Step 3 is where the magic happens, the unicast conversion. This is the crucial moment. The relay agent takes that untargeted, chaotic broadcast and converts it into a highly targeted unicast packet, meaning it now has a single, very specific destination. The relay agent packages the request and zips it directly to the exact IP address of your central DHCP server, slicing right through those network routing tables without causing any broadcast congestion whatsoever. And finally, Step 4, the response. The central server gets the request. But wait, how does it know what IP to give out if the device is miles away? Well, it looks at the gateway's IP address, which was handily provided by our relay agent, to figure out exactly which network segment the client is sitting on. It picks an IP from the correct scope, unicasts it right back to the relay agent, and the relay hands it off to the client. Boom, the connection is made. Let's talk real-world value in Section 4, key benefits and savings. This isn't just neat technology for the sake of it. It has massive real-world implications for your bottom line. Implementing DHCP Relay gives you 3 huge benefits for your infrastructure. complete centralization, incredible hardware savings, and the prevention of nasty IP conflicts through better load balancing. First up, complete centralization. With DHCP Relay, you are totally empowered to seamlessly assign and manage every single IP address across all your different networks, VLANs, or subnets, entirely from one centralized server. You don't have to bounce around between different interfaces or physical locations. You get to manage your entire IP infrastructure from a single pane of glass. It's a lifesaver.
Second, let's talk financials. You completely dodge the massive cost and high maintenance headache of deploying physical hardware DHCP servers at every single location. Setting up a separate server for every branch office is, quite frankly, incredibly expensive, both for the initial hardware and the endless labor needed to maintain, patch, and secure them all. With a Relay setup, your hardware costs absolutely plummet.
And third, preventing network crashes. By utilizing centralized servers, you can distribute your workloads seamlessly. This balances the load, keeping local servers from getting completely overwhelmed by sudden traffic spikes. And honestly, more importantly, maintaining a single central authority for IP assignments drastically reduces the chances of those localized IP conflicts that can just knock critical devices entirely offline. If you want the nitty-gritty on exactly how to configure these Relay agents to handle and route these messages across different hardware vendors, definitely check out the ZenArmor DHCP guide for a really in-depth look. But I want to leave you with this final thought. Take a hard, honest look at your own infrastructure today. Is your network truly optimized? Or are you secretly wasting a ton of time and money maintaining way too many local servers?
Thanks for watching.